Hello everyone. So this is a tutorial on how to use NGLess to process a metagenome. And so first, just a note, I'll record this tutorial in a couple of languages. And so now I'm doing English, and below you can click, I'll probably do at least French, German, and Portuguese. And so click there if you want other languages. Although, I mean, the message here is in English, so I don't know if you really don't understand it, I don't know, but maybe it's more comfortable. Anyway, so you have a metagenome, and that has come to you as a pair of FASTQ files. So it's a paired end, and what we're going to do is we're going to use NGLess to assemble it, and then we're going to map the reads back to the contigs that we've just assembled. So that's, we first assemble and then map the reads to the assembly. And before that, we just do a little bit of quality control on the reads, a little bit of read trim filtering. So let's start. So here, I'm going to start from scratch, and I'm going to say you have here a Linux machine, and I'm just going to first install, and I'm going to use Conda. Actually, I'm using Mamba, which is the fast version of Conda. So basically does everything that Conda does, but faster. So just create a new environment, and here now I'm going to install NGLess, and so I have to say that I'm using the channel BioConda and install NGLess. And this might take a couple of minutes even if you have a slow internet connection. So in my case, I pre-downloaded everything before the tutorial, so everything's already there. And now I'm going to write the NGLess script. So the way that NGLess works is that you write a little script, and you can think of it as kind of its own little programming language. That's a very simple language that describes what you want to do. And so it always starts with this line that says NGLess, then a version number. So here we're using version 1.5. And so then we can use, there's a couple of different modules that are optional. So here we're going to use SAMtools because we're going to need it a little bit later. So we import that, and we also say that we want version 1 of the module. And so this is the version of the module, not necessarily the version of SAMtools. Then we load the data. So this is the paired end data. And so below you'll also find a link to the GitHub repository where we have this script, and we also have how you can download this if you want to follow along at home, do everything. So everything's there. So we load it with this paired function, and then we pre-process it. So there's again this pre-process function, and we write this little block of code where first we substream, which means we trim the reads, and so that every base pair has a minimum quality of 25. And then if at the end of this process we have fewer than 45 base pairs, then we discard the read. Otherwise, we proceed, and we call the assemble function, which is going to call megahit. And then we call the write function, which writes the contigs to disk in a file we're going to call config.fa. Then we call the map function, which in this case, by default, is going to use BWA to map the input reads back to the contigs. And then we sort it using SAMtool sort, and then we write the BAM file as well. So I'm going to exit, and now on the command line, we call NGLess. -J80 means use 8 threads. Makes things a little bit faster, unfortunately not 8 times faster. And now it's running. And so this is going to take a little bit. So I'm going to do this, and 1, 2, 3. Okay, and I've moved forward in time. And as you can see, if you see the time logs, it took about an hour for the first step, which was to build the assembly, and then another 12-13 minutes for the following steps of doing the mapping. You can also see that about 76% of the reads mapped, which is a very good number. You never get 100%, but 76 is actually a pretty good number. And so we can see now as well that if we look at the files, we can see that the files that we wrote are there, config.fa, output sorted BAM. If we look at the config.fa, here are the contigs, and we can use SAMtools view to look into this BAM file, and we can see that it looks, as you'd expect. So if you've looked some of these files, you'll see that this is what you get. Right, so as I said, everything is in the GitHub below, and I will do a follow-up tutorial where we will use SemiBin to now take this and build metagenome assembled genomes, so mags out of this. So follow us to get that, or click below to find the other languages as well. So, and if you have any questions at all, please feel free to reach out. We can schedule a Zoom call. You can email, DM on Twitter, Discord. I mean, we're very, very open. You can even comment on YouTube and we'll monitor those. All right. So thank you. See you soon.